Hi, today I'm going to talk about electrons and hole. Let's start. First, let's talk about longitudinal direction. In here, we can know about the direction of electrons and longitudinal longitudinal direction means the where electron moves. So the direction of which is electron moves. So we call that direction longitudinal direction, and the other direction, the opposite direction, means transversal direction. Then based on this longitudinal direction, we can calculate the effective mass of through the longitudinal direction. Um, so this m means longitudinal direction effective mass. Then let's look about this AK diagram. There are two graphs of light hole graph and heavy hole graph. In this graph, the light hole graph is more effective than heavy hole graph because it has higher curvature. So this light hole graph has smaller effective mass and smaller effective mass, so carrier can move more faster than heavy hole graph. So light hole graph is more better than heavy hole graph, and in the middle of this graph, that blue circle, there are heavy hole and light hole are coexist in there. So we can find heavy hole and light hole everything in that blue circle. So based on this graph, we can calculate this, we can make this equation. This is very important equation because the carrier is important. The velocity is important to move carriers. So this equation means the velocity of electron. So we should know this equation. Then let's talk about intrinsic semiconductor. About in this concept, we can know electron and hole and carrier concentration is same because if electron moves to another place, electron makes the hole. So electron and hole and electrons number are same, and also carrier electrons mean carriers, so electrons and hole and carriers concentration is same in intrinsic semiconductor. So based on this concept, we can make the equation like this: mass action law. This is very important to solve semiconductor problem. We can calculate the hole and electrons carrier number based on this equation. Then let's talk about quasi-free electron. Electrons can move freely in material or semiconductor. So electrons can recombine in anywhere because electrons can move anywhere, and so in result, recombine can also happen in anywhere. So that electron which is recombined in anywhere means quasi-free electron. So we use quasi-free electron in semiconductor. There are two types of semiconductor: N-type and P-type semiconductor in here. And let's look about N-type semiconductor. There are one more electron in here, so this semiconductor acts like negative charged ion. However, in p-type, there are empty place in here, so it this semiconductor acts like positive charged ion. We use these two types semiconductor, so we should know the concept very well. Then I will talk about donor and acceptor. Donor is the atoms donate electrons to semiconductor. So this used in n-type semiconductor because n-type semiconductor has one more electron, so we should donate electrons. So donor works to donate electron, and acceptor works in p-type semiconductor because p-type has one empty hole, so someone should take the electron another place. So acceptor means the atoms accept electrons from semiconductors, so we use acceptor to make empty hole in p-type semiconductor. Then let's talk about impurity. There are three types of impurity. First is vacancy. There are empty hole in the middle. So it is very not good. Not good. Then let's look substitutional impurity. This red atom is exchanged. So yes, exchanged. So we call substitutional impurity. Then last one is interstitial impurity. There are one atom is the middle in here. So yes, this means impurity. This impurity. Then we use substitutional impurity the most to make semiconductor because it works very well, the best in better than the other two. So in semiconductor we use this substitutional impurity. Then last, let's talk about Hall effect. Based on this circuit, we can calculate the voltage VH. By measuring the voltage VH, we can identify the n-type and p-type semiconductor because if we measure the polarity of voltage, we can divide it, the n-type and p-type semiconductor. Then also we can calculate this equation based on this circuit. After we calculate the voltage of this circuit, we can know the carrier concentration. So based on this Hall effect, we can calculate carrier concentration, and this is very, very important key of making semiconductor. So Hall effect is very important to make semiconductor. So today we talk about electrons and Hall. Thank you for watching my video. Bye.